So we all know that iron nails don't burn, but iron wool will smoulder and iron filings will spark in a Bunsen flame. This is a surface area effect, maximizing the contact between air and the metal. If we can get extremely small pieces though, is it possible that iron could burn even without a flame? Let's find out. When I was first training to teach and looking for good ideas for chemistry lessons in terms of practicals and demos, there were two reliable texts that I could always go to: classic chemistry practicals and classic chemistry demonstrations. Whilst much of the health and safety guidance is now out of date, they're still worth tipping into for ideas. There was one demo I always wanted to try for showing surface area effects, but I was always a little bit put off by not having had iron ethanodioate in stock, also known as iron oxalate. If I had read on, I would have found out it's actually quite easy to make from chemicals you're more likely to have in the cupboard. So today we're going to make some of this and decompose it to produce an extremely fine powder of iron which will spontaneously combust in air. Obviously you can make as much as you like, but in the instructions I've gone for quantities that will yield enough for around 4 demonstrations. Simply make up some solutions of sodium ethanodioate and iron sulfate. For further details, as always, check out the accompanying article on the EIC website. These two chemicals can be combined to precipitate out the iron ethanodioate. Once you have the two solutions, combine them, filter off the lovely yellow precipitate you get, and leave it to dry overnight. It's then ready for demonstrating with. Once you're ready, simply take 2 grams of your iron ethanodioate, load them into a borosilicate boiling tube, and use some mineral wool to loosely plug the ends so that fumes can escape, but any powder will be retained in the tube. Work in a well-ventilated area because carbon monoxide is going to be released in the reaction. As the sample is heated, water of crystallization is first released. You'll see condensation further up the tube, and the sample will begin to turn black. So although when I first filmed this, I did so using the tube held in a clamp stand for ease of focusing, I actually recommend that you do this using a handheld test tube holder, a little bit like this one. And that just allows you to agitate the mixture and make sure that you've got some even heating. That allows the reaction to proceed a little bit better. As we reach these sort of higher temperatures and the water of crystallization is finished coming off, what starts to happen is that the evolved carbon monoxide begins to reduce magnetite that's in our mixture here, and that reduces it down to these very ultra-fine particles of iron. Also, iron carbide thermally decomposes to produce more iron, and we get this really fine powder here. And as I'm agitating this mixture, I'm able to sort of determine when the gases are sort of finished coming off, because the viscosity, if that's the sort of correct word to use here, of the powder sort of increases. It stops flowing around quite so much. I get the sense that it's pretty much finished reacting, so I can take off the heat. I'm only using a blowtorch for ease of filming. Of course, there's no reason why you can't use a Bunsen burner. And give your iron powder a little bit of time to sort of cool down. Any sort of carbon monoxide in here will maintain this in a reducing environment, so you'll be able to sort of keep the powder for your demonstration. And then when you're ready, I recommend obviously sort of working in a slightly dimmer room, so I might actually go and sort of pull a blind across momentarily. Take out the mineral wool at the top, pour out your powder from a reasonable height onto a heat-resistant mat, and you get these lovely smouldering particles of iron, demonstrating the importance of high surface area in kinetics. So there we go, very simple. All you've got to do is heat up some yellow powder, pour it out onto a heat-resistant mat, and you're golden. Really good, quick, simple demonstration of surface area effects. Give it a try, and if you do, let us know in the comments how you got on with it. See you next time.